Welcome to the virtual classroom. Today I will teach you the topic, the reactivity series of metals. I have made this lesson from the book Federal Chemistry. Number 246. Let's go through the reactivity series. You all are watching a picture of elements. This is called reactivity series from potassium to platinum. What is reactivity series? Reactivity series is a list of reactive metals in which metals are placed on basis of their reactivity. How they are placed? The most reactive metals at the top, the least reactive metals at the bottom. So it is very easy to understand that the metals which are very active will take place at the top, and the metals which are not much active will take place at the bottom. Okay, so how do you determine the reactivity of metals? Here you can see. Before going through this question, I would like to ask you, I would like to inform you that through this lesson, we will get to know many questions like why, what, how it has been made, so many questions. So I would like to request you to ask me many questions like this, because chemistry is why, how, and what. Okay, so before going through this question, how do you determine the reactivity of metals? I would like to show you a picture. Who is more active, right? Obviously, the boy running at the front is more active than the boy sitting at the back, right? As I can give you an example, that is the students right now who are sitting in front of the laptop or mobile, whatever it is, and giving their attention to take this class. You all are very active, while many of the students are wasting their time. They are not giving their attention. They are not actually attending the virtual class, so they are not active. Okay, so how can we relate the reactivity of these elements in terms of elements as we are learning chemistry? So the metals which are participating in a reaction very easily, we would call these metals or these elements very active. So the metals which is taking part in a chemical reaction easily is active. Okay, so reactive metals form positive ions easily. How they form positive ions? Exactly by losing electrons. You already have finished the chapter chemical bonding, so you know how chemical bonding works: ionic bonding, covalent bonding, metallic bonding. So in every bonding, you can see that. In ionic bonding, the metals actually lose electrons. So we know that. Let me ask you a question before that. That is it important to lose electrons? Yes, we already know that to take part in a chemical reaction of elements or to make compounds, every element has to remove or donate electrons or receive or accept electrons, right? So the metals remove or donate their electrons, and non-metals receive electrons. So here we can see that sodium is removing or donating its one electron, forming sodium ion. So why forming positive ions is important? Because without positive ions it will not make compounds. As you can see, sodium plus, it is actually uh, donating its one electron to chlorine, and then chlorine receive one electron and form sodium chloride. So sodium chloride is a solid form. The sodium chloride is a salt, the salt we take in our daily meal. So here you can see the very important uh, to note down that the internal state of these ions are solute, that is aqueous. Aqueous means when an ion or solute is dissolved in water. That means when the solvent is water, then we will write the internal state as aqueous, and solid, we know what is solid. Okay, so by losing electrons they actually form compounds. Actually they take part in chemical reactions. So the the metals which form positive ions easily is more reactive, right? So here you can see two elements, potassium and calcium. The atomic number of potassium is 19 and the atomic number of calcium is 20. They both have four the four shell in their atom. So the outer shell of potassium contains one electrons and outer shell of calcium contains two electrons. So I would like to ask you another question, that is, which elements tends to form positive ions more easily? Or just tell me, removing one electron is easy or removing two electrons is easy? Obviously, potassium can donate or remove its outer electron very easily because it has only one electron, while calcium has two electrons. So potassium will form positive ions more easily. So potassium will take place or take part in a chemical reaction more easily than calcium. So we can say that potassium is more active than calcium. As you can see here, potassium is taking place at the top and calcium is taking place at the third position. So because potassium is more active than calcium, I would like to inform you and note, that is, all of these metals have not been made with this justification that these metals can, the more metals can donate its electrons, it will take place at the bottom or top. Sorry, it's not like that. It actually, there are so many factors to determine which elements or which metals will take place, right? This is one factor that I have discussed, that the element which can remove or donate its outer electron easily, it will take place at the top. There are so many other factors which already determine the position of these metals or the position of the reactivity series. So what about unreactive metals? Unreactive metals tend to prefer to remain in uncombined form. So as we already have given their name of these metals unreactive, it actually means that they will not form positive ions or they will not take part in chemical reaction that much easily as like potassium, sodium or reactive metals. An example is gold or aurum. As you can see again, the gold is taking place at the bottom because it is less reactive than those metals. That's why it is taking place at the bottom. So this is less reactive, right? Now, I would like to ask you, have you observed any differences in this picture, or have you seen any bizarre things in this picture? Yes, many of you have already noticed that there are two elements, that is carbon and hydrogen, that are being red marked. So why they are put in this series? They are not metals. We know that they are not metals. Carbon is non-metal, hydrogen is also a non-metal because it is a gas. So why they have been put in this series? Because there are so many factors. One factor is this actually function as indication to extract the metals. There are so many methods to extract these metals. We have to actually extract these metals from the nature, from their ores. ORES. I hope you already heard the name ores. Um, so from nature we have to extract these metals. So carbon and hydrogen actually gives us an indication how to extract these metals. And another factor is hydrogen can also donate one electron. So if the properties of metals and hydrogen is slightly similar, that's why we can put hydrogen in this series. Okay, so mnemonics to remember reactivity series. Is it important to remember the reactivity series? Yes, sometimes it actually helps us to answer so many of questions. Though sometimes you will be given the reactivity series in your question, but if you can remember the reactivity series, it will help you. And there is it is very easy to remember. That is, please stop calling me a cute zebra. I like her. Call me smart coat. It is so easy. It's not so tough to remember, right? So by reading this line, you can write all of the metals serially. This is reactive metals. This is the this actually indicates the reactivity series. Please, potassium, stop, sodium, calling, calcium, B, magnesium, A, aluminium, cute, carbon, zebra, zinc, Iron like lead, hydrogen, coal, copper, me, mercury, smart, silver, gold, and gold platinum. Okay, so how reactivity series is made? This list was created experimentally by studying the reactions between metals with water, steam, acid, and oxygen. Okay, so the reactivity series was made actually by reacting metals with water, steam, acid, and oxygen. As I have already discussed that how metals form positive ions, it actually donate electrons. So is it that much easy to experiment how the metals are, how reactive the metals? Can you think of that? You are putting a sodium in your hand and you are observing that sodium is donating in this drum or not. Is it possible to observe this experiment this way? No, it is not possible. That's why what we can do is we can make them reacting with water, steam, acid, and oxygen, so that through making this reaction they actually form positive ions. They actually give donate electrons, and then they will take part in a chemical reaction with this reactants, and this way we can make a comparison that how reactive how reactive the metals are. Okay, so reaction of metals with water, steam, and acid. If there is a reaction, the metal displaces hydrogen, producing hydrogen gas. This means that if the reaction take place with metals of water, steam, and acid, there will be hydrogen gas. Always you will get an hydrogen gas. No matter what the reactant is, it is water or acid, you will get hydrogen gas. As you can see the equation, metal plus hydrogen ion, metal ion, hydrogen gas. And here M means actually metal. This is general formula, and hydrogen ion, H plus. As you please note it down that here H plus means actually it can be an water or acid, because water contains H plus or hydrogen ion, acid also contains H plus ions. So we have not indicated here any specific water or acid. We just wrote H plus, so that it means actually H plus, and it actually means that it can be water or acid. As you can see, what acid, hydrochloric acid, HCl, it contains H plus. Sulfuric acid, H2SO4, it also contains H plus. And another acid like nitric acid, it also contains H plus. So H plus means it can be water or acid, and no matter what you are using, you will get an hydrogen gas. So it is an indication of this reaction. So at the top of this reactivity series, potassium, sodium, and calcium, it actually react with water very violently. Why I have made two column, cold water and steam? Because actually it doesn't need to react with steam, because steam has, I hope you know the difference between water and steam, right? Water is liquid form of water and steam is gaseous form of water. When we heat water, it actually gives off as steam, right? So when you add water with potassium, sodium, calcium, it reacts violently. You do not need to react steam because before before steam, it actually react violently with cold water. So we do not need to add steam. As you can see, test for hydrogen gas. I know, and I can hope that you everybody went through this experiment in the laboratory, that is testing for hydrogen gas. As you can see, potassium and water will react violently and producing hydrogen gas. And how do you test the hydrogen gas? The lighted splint, if you take place a lighted splint at the top of the tube, this lighted splint will light will goes off, and with a pop sound you will hear a pop sound. Okay, reaction with water, sodium, water reacts making sodium hydroxide and hydrogen. As you can see, the equation, sodium, water, that is liquid form, sodium hydroxide and hydrogen gas. Internal state is already given, so it is very important to note this internal state. And whoever facing problem balancing this equation, you can ask me later, so that I will take another lecture and lesson to introduce you or teach you how to balance the equation. Okay, so now we will go through a question: why reactive metals like sodium and potassium are stored under oil? You already know the answer, as we know that Metals can react with water very easily. So why we need to store them under oil? We can store the metals in the air, right? No, no, right? Because the air contains water. Have you heard about that air contains water? Yes, air contains water vapor. That's why these reactive metals can undergo a violent reaction with this water residing in the air. That's why we cannot keep them in air or environment. We have to put them under oil because so that water vapor in the atmosphere cannot react with them under oil, because under oil there is no water vapor or there is no water. Okay. I hope you everybody have understood this question and answer. It is very important to know and it is very interesting also. Okay, let's go to the middle of the reactivity series. It is magnesium, carbon, zinc, iron, aluminium. They do not react with water. Actually, they do not react with cold water, but they react with steam. Why? Because steam has heat, right? This heat actually helps to made these metals to react with water. This cold water cannot make them to react with water because there is no heat and there is no such other factors to make them so reactive, and they are not that much reactive but slightly reactive. So that needs some factors, that is steam or heat, which make them to react with water. Reaction with the steam, magnesium oxide, hydrogen. And very important to notice that water is written in gaseous form. So it is very important. It is not liquid. So it is forming magnesium oxide and hydrogen. As we know that hydrogen gas will be given off. Okay. So as another example, like zinc, water in the gaseous form will form zinc oxide. So now we already have discussed two metals reacting, one with water, that is sodium, another is magnesium, which is reacting with water of gaseous form, that is called steam. Both are forming different compounds. Have you noticed it? Sodium is forming sodium hydroxide, magnesium is forming magnesium hydroxide. Why? Sorry, magnesium oxide. So one thing and one question has arise in my mind, that why not magnesium hydroxide is formed? Okay, so to know this answer, um, I would like to know you that the metal hydroxides, as you can see, why some metals form metal hydroxides while some metals form metal oxides. Metal hydroxides are not very much soluble; they are insoluble, and the answer is metal hydroxides are insoluble and they thermally decompose to give the oxide. Thermally decompose, a very important term to know. Thermally decompose. As you know, while metal like magnesium is reacting with water of gaseous form, that is steam, it is forming actually magnesium oxide. That means that this steam has heat, right? So thermal means actually heat. So this heat actually decompose magnesium hydroxide to magnesium oxide. It is not that magnesium hydroxide is not forming. Magnesium hydroxide is also forming, but for a very little time, very short time, so that this magnesium hydroxide decompose to magnesium oxide within a fraction of time. So who actually made this possible? This is heat, that is thermal decomposition of magnesium hydroxide actually decomposed to magnesium oxide. Okay, so let's move through the last of the reactivity series, that is these metals that do not react with cold water, that do not react with steam. Because as we know that these metals are less reactive, so cold water and steam, they do not have that much energy, they do not have that much power to make them to react with water or steam. So that's why they do not react with water and steam. Okay, so now let's move through the column acid, reaction with acid. Before going through the reaction with acid, I would like to show you a term mesh. I hope you know what is mesh or who is mesh. Yes, mesh is Mashraf ibn Murtaza. our uh, captain, former captain of Bangladesh cricket team. So if you know the match, so you will be able to understand, or you will be able to memorize what will happen when metal and acid reacts. Metal, acid reacting, when react they form salt and hydrogen. So it is very easy to remember, right? So as we know that when metal will react with acid or water, it always form hydrogen. Okay, so what happened to again the top reactive metals with acid react violently with dilute acids. Okay, so react violently with dilute acids. Now let's go through what is dilute. I know you, many of you have heard about the dilute or dilution. Dilution is actually when the acids are mixed with water. That means the acid is mixed with water. There is the portion of water is higher. The content of acid is less, but the portion of water is much more than acid. So as we can see that when these acids are reacting with water, they react violently. So the same thing happens to acid because this is dilute acid. That means there is a more portion of water. So why not they will react with water? They will react water violently. So here they will react dilute acids very violently. And there is an observation, that is potassium and sodium. Potassium reacting with hydrochloric acid will form potassium chloride, a salt, and hydrogen gas. And sodium also reacting with hydrochloric acid form sodium chloride and hydrogen gas. This is to an example I have given. And these reactions are very explosive. That's why we advised not to carry this reaction in the school laboratory because it can make accident. Let's move through middle section of the reactivity series. Again, they will react with dilute acids, but with decreasing ease. Okay, so why with decreasing ease? I'm going to take this question with the answer. As you can see, magnesium and hydrochloric acid. Now, have you observed how magnesium chloride is forming? Yes, magnesium is actually removing hydrogen or replacing hydrogen, and magnesium taking place of hydrogen, pushing out hydrogen. That means magnesium is actually releasing hydrogen off. So why magnesium is replacing hydrogen, not hydrogen to magnesium? Because as you can see the reactivity series, magnesium is taking place at the top than hydrogen. So it is upper than hydrogen. That's why it is more active than hydrogen. That's why magnesium can easily replace hydrogen from the acids. This way, magnesium easily replace hydrogen and form magnesium chloride and hydrogen gas. So every metals react with this way. As you are going through down, the metals are becoming less reactive. That's why they will find very difficulties to react with dilute acids. That's why we are writing that it will react with decreasing ease. Okay, so there is another example, iron, the same way it will react with very, it is called ferrous chloride, FeCl2, and it is also forming hydrogen gas. Okay, so the lastly, the the least reactive metals, they actually do not react with dilute acids. They react only with concentrated acids. Okay, it is an exception. As you know that the metals sitting below the hydrogen, they cannot replace hydrogen because they cannot replace hydrogen because they are below the hydrogen, right? So they cannot remove hydrogen. So metals below hydrogen will react only with some concentrated acids because those concentrated acids function as a strong oxidizing agent which oxidizes the metal to its oxide. So it looks very difficult for you to understand as when you will go to the next class. I hope you will get a better understanding of this term. So you do not need to know the details of this term now. Just read it through, and it is an exception. Which are the concentrated acids? Just know the name. The nitric acids and sulfuric acids, when they are concentrated, they can actually react with least reactive metals, copper. As you can see here, nitric acid and copper, and though copper is sitting below the hydrogen, it is not actually replacing hydrogen here. As you can see, here is no hydrogen, it is forming water. So this is an exception, so you do not need to know the details of this reaction. Just go through the reaction, and I will discuss this question later. Why aluminum reacts more slowly than zinc and iron? Okay, so let's go to the another question that is very important. As you can see here, aluminum, carbon, zinc, iron, where aluminum actually do not show the reaction like other metals. Actually aluminum behaves differently. Why? There is a question, why aluminum reacts more slowly than iron and zinc? Why aluminum reacts more slowly than iron and zinc? As I am taking back to this series, as you can see, iron and zinc is sitting below the aluminum. So, in generally, aluminum has to be more powerful, right? Aluminum has to be more reactive than zinc and iron, but it is not. Aluminum actually reacts more slowly than zinc and iron, though they are sitting below the aluminum. Why? Because there is an aluminum uh, oxide that is called protective oxide coat on its surface. I hope you or everybody have observed the aluminum sheet in our home, or aluminum sheet. So aluminum sheet contains a protective oxide surface on the upper surface. How it has been made? It actually made by when aluminum is when we put an aluminum sheet on the ground or in an environment, it actually reacts with water. The water vapor residing or in the environment with reacting with water, it actually forms this protective oxide surface. So that's why it finds very difficult to react with acid and water. That's why aluminium reacts more slowly than zinc and iron. If we can remove this surface, then this aluminium can react with acid or water more faster than iron and zinc. Okay, so it is very important question, and I hope uh, you everybody have understood this topic. Okay, now let's go to application of reactivity series. Actually, there are so many application of this reactivity series, so I have only put three of the application as written in the book. It helps to explain the stability of metal compounds. Though we have discussed a little bit of metal compounds, like as I have discussed that magnesium hydroxide will decompose to magnesium oxide because of thermal decomposition. How have we made this explanation? So reactivity series. This is another uh, application that it helps to explain the stability of metal compounds. So there are so many metal compounds we have not discussed in this class. We will discuss on the next class. And the second application is the displacement power of metal. As we have seen that the metals sitting above the hydrogen can displace hydrogen. So how have we made this indication? Through the reactivity series. So how a metals displace a hydrogen, or how a metal displace another metal, we can get a better idea by seeing the reactivity series. So we can know the displacement power of metal, and the lastly extraction of metals from their ores. So extraction of metals, there is another chapter named extraction of metals for O level. So we will not discuss the topic now or on this in this class. We will get to know this topic on the next class, extraction of metals. So I have given here two homework from the book. If you go through this book, you will get to see this topic, these questions. And I hope I already discussed all of the questions from my lesson. So if you go through the lesson, you will be able to answer all of these questions. As you can see here, can you name two metals below copper in the reactivity? Yes, you can name two metals like mercury, platinum, mercury, silver, platinum, and so many other questions I have already discussed. So you this two pictures is given as homework. So you will solve this question and submit to me the next class. Thank you. Thank you so much.